Okay? So it's going to hinge on negative 2x plus 3. So let's take a look at this. If y equals negative 2x plus 3, and they give us the range of 0 to 1 here, this is your A and this is your B. Those are your left ends and right ends. Okay? Now, right here it says delta x equals b minus a over n. N is the number of columns that we are actually going to deal with. So delta x equals b minus a over n. So that is basically what is my tiny little axis going across here. That is the base of each of these imaginary rectangles going up. Okay? This is CI, which is, C denotes a small value between the two i's. And we have A, which is here 0, and delta x, I should probably put the A equals delta x there, and then put the values in there to go through this. So, b minus a, 1 minus 0, over the unknown n. So this, of course, gives us 1 over n. C sub I here, then is going to be equal, and this is the y value, this is the height of these rectangles. This is going to be A, in this case, which is 0, plus, realize I've got to put time I. You should have a time I right here. Okay? So, this is going to be equal to 0 plus delta x, which is 1 over n, times I, which becomes I over n. And that is going to be the height of our y values, of our rectangles. Now, since this is technically the y here, when we come over here, to solve for y, to get those values, I'm going to plug that in for x right here, because we're dealing with that delta x in there. That's going to go right here for x. So I'm going to rewrite this. I'm going to forget the y here. In fact, at this point, we're going to talk about the limits that are being created from all these rectangles. So the limit from n approaching infinity, and we're doing infinity because the more number of columns we have, the more likely we're going to get the right answer for the exact value of the area. And then we put in our summation, because we're going to add all these little columns together, going from I equals 1 to n. And this is going to be in front of everything, and I'm probably going to be not putting this in, but remember, we're doing limits and all these just to save time to get through this. And then the equation, negative 2x, so it's negative 2 times, and then this is where we put our CI, that's our y, times delta x. This is the formula we're using for the negative 2x part, and then plus 3 is our final aspect of that. Okay, now I'll plug in for CI and delta x. So this becomes when you put dittos here, I'll probably do probably not do it for this, but I will definitely do the limit. It's always going to be there. So negative 2 times CI. What did you say CI was? I over n. What did we say delta x was? 1 over n. And then plus 3. Now, please be careful of this, and I have seen this happen where people start to ignore this plus 3. It's happened on earlier assignments that we've had, and it's probably going to happen again. I'm going to like sort of go, what happened to it? What happened? So please be cognizant of that. Okay. So what we're going to do next is I'm going to combine this together. So this becomes negative 2i over n squared plus 3. Now I'm going to break this up into two summations. I'm going to take the summation of this plus the summation of this. So this actually should be in parentheses because this is the summation of the whole thing. But now I'm going to break it up into two parts. So I'm going to have the summation, again, limits all over the place, of negative 2i over n squared plus the summation of 3. Now this is where page 260 becomes really important because, well, it's about to. But this right here is the first part of the first example they have of page 260, which deals with summations of numbers without variables in a context like this. And we'll come to that in just a little bit. For this, what we're going to do is the only thing affected is going to be the variable. We are going to say that 2 and n squared are going to be a constant once we've established what n is. In this case, since the limit is infinitive, n is equal to infinitive, but we're not going to eliminate it just yet. We will eventually. But for right now, it's part of it being a constant. So that's going to get pulled to the outside. It's going to be negative 2 over n squared times the summation of n over I equals 1 of just plain I. And that's really our goal, is to get just I or I squared or I cubed or a number by itself so that we can use that chart on page 260. That's really important. Plus, and this is just the summation of I equals 1, 3. Okay? Now, yes, we've got limits all over the place. There's a limit here, there's a limit here, blah, blah, blah. And going to infinity is basically what we're looking at. Now, I'm going to put in 2 over n squared times. Now, according to the chart, the summation for I, for a series of i's being added together, is n times n plus 1 all over 2. Plus, then over here, since it's just 3 by itself, this becomes 3n. Okay? Now, I forgot. So, and this is one thing I forgot to put in there, and I should know better than that, but I didn't. This whole thing, I haven't put in the value for delta x. So this was all y, and this is going to be 1 over n. And so this is 1 over n here, and this is going to be 1 over n for the whole thing. Okay, that's my delta x that I have put in. Everything we've done up to this point is all y's. So I'll put 1 times 1 over n here, and times 1 over n here. So now what I'm going to do is I'm going to distribute this 1 over n by both of these parts right here. So this becomes Go back here. Oh, I had done that with that. I already done it with this. So this is just this right here. 3. This is 3. And this is 3 right here. So I had already done that. That's where I got the n squared from, but I forgot to do it with 3. See how easy that is to forget? So that's my bad right there. So this has been taken care of over here. That's where we got the n squared. But I have to multiply this right here. So I will put that in right now. Negative 2 over n squared. And I'll go ahead and multiply this out, which is n squared plus n over 2 plus 3. Remember, we still have that limit going on here. We have the limit as n approaches infinity. Always in the back of our mind, we know that's going on. Okay, so I'm going to cancel out the 2's right here. And that's going to leave me, of course, just 1. And because it's negative, 1 over n squared times n squared plus n plus 3. Now, that's going to give me a negative n squared over n squared, which is a negative 1, minus 1 over n. Now we get to that limit thing. And since the limit is infinity, that becomes 0, and that drops out. Plus 3, we got negative 1 plus 3, so the answer is 2. Our area is 2. So, bottom line, don't do what I did there. Forget to put my delta x in there for each term, not just one term. Every term has to be multiplied by delta x. Okay? So, like I said, this is fraught with possibilities of tiny little screw-ups. And many of you are really good at that, and I'm no better than you are, of making tiny little mistakes. I can't tell you the number of times when I've been trying to break this down, and I'm going, where did I go wrong? It was just the tiniest, stupidest mistake possible, and I did it, because I'm really good at it. Be careful of that. And don't get upset when I point out to you, because it's normal. You just got to get to a mind frame where you got to slow down, do the problem very slowly, step by step, to make sure that you minimize the number of mistakes. So evidently, the limit of doing this assignment is approaching 0 from this thing. There we go. Okay. This is the next problem.